So, my name is Sebastian. I'm from Poland. I'm here today to talk with you about code quality and the standards that we use when we want to develop something. I have like around 10 years of experience as a freelancer. I spent most of the time in fintech projects. I started as a backend developer, then front-end developer. Then I started working as well with cloud services, and then somehow I became the software architect, basically. Today I'm the CTO of CodeJet. This is the startup for 1.5 years. We're on the market. We won Product Hunt last year with our idea, and we are visiting with my friend, co-founder Patrick, for these 2 weeks San Francisco to share the knowledge, to meet new people, and we are really excited that we have the opportunity to be here today. So, test-driven development. Normally, we can think about using basically the good standards to create the code or the solutions, but after a while, I realized this is basically some kind of switched mindset that helps for us to perform better. And it's not only about the coding, but I will explain all of it soon. So there is one way to do something quick. And as Uncle Bob said, this one way is to do it right, basically. So we always think like, okay, let's do it fast, and then we can improve that or fix that. Basically, it is always preparing ourselves for failure. So for sure, we need to be focused on the best solution at the moment that we can provide. But it costs extra time, and we know about it. Let me just open one more thing. Okay, hope you can see my mind map. Okay, so we can jump further. So this is the startup I'm working on with my co-founder, Patrick. He's sitting there. And we basically just take the design from Figma and change that into the static websites. So this is our goal for now. But I'm here to talk about test-driven development. In last almost 10 years, I've been lecturing about the front-end and back-end technologies at the private boot camps. And as well, I'm teaching at a university, and I'm teaching young entrepreneurs about how to create startups following the lean startup methodology and total quality management, and as well all the practices that help for them minimize the costs and maximize the value that they can provide for the customers, for the clients. So the joke with my friend, that we made with my friend, was that test-driven development is for people that basically they don't believe themselves. Like when you think you make some mistakes, then basically you should use this test-driven development, and it's funny. But the truth is, our brain. We want to believe that our brain works in amazing ways, and we design amazing processes, but after a while, I find out in most of the cases, we basically developing new features using brute force. So we are trying something and push it forward a little bit, and we are improving and improving. And this process costs us a lot of energy. So we need to think about 7 fundamental questions of development. So these are the questions or dilemma that I have basically constantly, and every time I talk with my team, I always ask about these things. Because in our company, we decided to use test-driven development since day one. And thanks to that, we had a really great outcome from that. Because today, the people are not afraid to do refactor of code. Because if you have everything covered in tests, then you are not afraid to refactor anything. You know what parts of the code can be impacted by the changes you did in the code, because all the tests will show you all the dependencies that you couldn't predict before. So how do we ensure our changes don't break existing functionality? So normally we believe that we understand everything, but when we think about chaos engineering, We know we have two types of complexity: the complexity that we know about, and the complexity that we don't know about. So it's basically for us hidden. So that's why we can never be sure how the changes that we are making in the software, in the architecture, basically, can impact other modules. It costs us a lot of. And why does the complex logic often lead to sleepless nights? It's more like when we are preparing some difficult solution, then basically we are at least two actors at the same time. So we are someone that is designing the process. So I'm right now designer. I'm thinking how I should create something. So this is my first role. But the second role is I'm the tester right now, because I need to somehow be sure that the small steps that I'm doing to achieve my goal, they are working and they are really directing me to the goal. So I need to work in two roles: as a designer. So as a designer, developer, someone who will think about all the cases that I should cover. And as well, I work as a tester of it. So I need to think about, okay, how to test that? How can is it really work? Should I move forward, or should I improve that somehow? Or should I go back a little bit? So this is why basically when we don't automate our tests during development, it can give us sleepless nights, because our RAM, there's a great book about how our brain works, and it's called Getting Things Done. And in this book, there is comparison of temporary memory from the computer with our brain. So basically, when we have too much processes in our brain, so we are switching constantly between these two roles, like the designer and the tester, then we basically use a lot of, let's call it, brain kilobytes for only switching. And because of that, whenever change we will do, we need, because, let's see a little bit deeper first, these two roles. So basically, when I'm developer, I work on the solution, I design solution, I improve solution, I keep tracking of work. What means I'm focused, okay, I have 3 definition of done points already done, I can move to 4th or 5th. And it means that I need to keep track all of these things basically in my head in most cases. When I work on the same ticket as this QA specialist, I think about test solution, what I should test it, how I should prepare the data for that. And I do it constantly. So I spend 8 hours working in this way. I'm really exhausted at the end. And for example, when I work on the ticket, on some simple ticket, and I need to prepare the data for that, then I want to change something, I need to retest that, and then I will change something, I need to retest that. So basically, I had to test the same part of functionality during the day like 100 times. But if I write first the test for that, I will write the test once, and then I can write the functionality that can pass this test. But we will move to that a little bit later. What is important here, when we are designing and building processes, for us is very important to keep our brain clean, to have like 100% of CPU at the moment to focus on one thing that's important for us. So designing new solution, or thinking about all the external dependencies that we need to cover, or thinking about the business requirements that we should be focused on, instead of jumping from one role to the another every 5 seconds. Because, as I said, the brute force itself is quite power consuming for us. So this is the question: are we just designing or just hacking through our problems? And we want to believe that we are just thinking about it, and it's like bam, we have the idea. We can somehow solve our problem. But in most cases, like, yeah, there is a small sparkle, but it's only ignition to start work. So we still need to somehow move it a little bit and change some implementation and test it many times. And in the end, unfortunately, we are using brute force. Of course, if we spend little time to think about it, so how it should work. I really love the Tesla engineer, and he had all the models in his head basically. So he just focused on this visualization because the power of his brain was very powerful, and thanks to that he was able to create prototypes in his head. But unfortunately, not he. Yeah, he hasn't have any social media then, so basically probably that can help for him, but not for us. So we have brute force, but when we invest that time in designing stage, like before we start and writing anything or creating, we can call it basically the soft brute force. So we can start, from not from like, yeah, we just need to write the software to open the window. So first we will take the nails and hammer because it will be brute force. But okay, we can see how we can open the window at the beginning. So this is this kind of soft brute force. And how can we be confident our code will work tomorrow? And I'm quite sure we all know that nobody can be confident about that. Yeah, like there is infinite number of scenarios where something goes wrong, and we cannot predict all of them. We can be prepared on something that in most cases occurred in our company or the competitor's company, but still there is, this black swan. So basically, yeah, we cannot be prepared for the black swans at all. And what is else quite important when we develop new stuff is this question: is it my fault or there are external dependencies? This is this always costs a lot of it's time inefficient basically, because when we don't have any tests for our software or our architecture, and we need everything test manually. So even before blaming anyone from the external dependencies, we should be sure that our code works properly. So first of all, we need to jump to the features. We need to do reverse engineering, how it should work, what was the edge cases, etc. And then we can test that. And after all these time-consuming process, we can say, okay, now we can start checking the external dependencies. And that's why writing tests is so important here. Because when we write tests, we can be sure that at least our code worked at the moment we wrote these tests, and today probably it works the same way as it behaved like 1 month ago when I wrote these tests. And as I said, why this verifying if our code works basically costs a lot of time, because sometimes we need to find the ticket in Jira when we are still working on this project, of course, read the definition of done and all the comments. There is sometimes some stuff that is missing in Slack communication, so we don't know how we should solve some architecture problems, and it was like in the history of Slack. And then we can just test our code, and then we can be sure that, okay, maybe it's not our code fault that the application doesn't work right now. And of course, yeah, do we remember the purpose of our modules over time? Absolutely not. It's like we are developing so many things every month, every year. It's like when I did something like 6 months ago and I don't have tests for that, I basically don't know what it should do. Yeah, it's like, yeah, I have the naming there, I have some kind of comments, but for sure the tests are always for me the best kind of documentation I can create, because it takes some modules and it gives some input and tests some output. So basically everything that is important at the first level of debugging. So why this test-driven development saves us a lot of time? The CodeJet, where we work with test-driven development, because we can quite fast find the root of the problem. So, as I said, if I can just run the test and see the results that everything in my code works properly, then I can, like, in 1 minute, start searching for the external dependencies, like API, for example. I've been working in 90 POE. I've been responsible for creating alarms that can communicate vessels with the operators on the shore. And I had quite simple task, like create some link that can redirect user from one product to another product, and there is the map. You need to pass in the link coordinates, and basically, thanks to that, the product page will open, and you will see your vessel at the correct position at the correct time. It was quite simple, but I'm working with test-driven development for like 8 years already. It's not like every day, so I'm not crazy. But still, this is one of my favorite tools to do something good and to do something right. So I decided to write first the tests. And what is important, I said, okay, I started writing the test, and then I realized I don't know half of the business requirements, basically, because it's so easy on definition of done. When someone from business says, yeah, it should work like this, this, and this. And we all know that basically we always agree, yeah, that's simple. But when we are starting coding that, then we see, yeah, okay, there is like 10 more requirements that should be think through, but nobody do that. And it is caused because we as engineers, we think a little bit deeper. We are more focused on these small details. We can see more scenarios, what can happen. And the business side just want to launch something very fast to check the response from the customers. So they are not really focused on details of implementation. They don't care about it, and that's okay. But still, we are the people that should demand all these requirements, definition of done, and we need to shoot as many questions as possible. And test-driven development is something that forces you to ask these questions at the beginning, because you need to write tests first. So you need to understand how your software should behave. And in the scenario when I was creating these links from one product to a second product, I realized that I don't know all the specs. So I asked the product owner, and he gives me some information, and I tested everything locally. Of course, on my machine works, so I deployed that on the dev, and on the dev, basically it didn't work. So I realized that there is something wrong, but it wasn't wrong with my software, let's say. There was basically some properties that they shouldn't be empty, but they are empty in real life. So I improved my tests, and I pushed the changes. I thought it will take around 1 day, but it took about 3 days working this solution. And after 3 days, I deployed that, and it worked on the dev. And after 1 day, the product owner came to me and said, Sebastian, it doesn't work. Okay, so normally, if I don't have this, very good test for that, I would be, oh yeah, this is my fault. Okay, let's check. And then I spent 5 hours or 6 hours investigating my own code, because I have the rule, because there is like, I always love that there is the pyramid of blaming. It's like the last level is you will find the fault in yourself, but the first is like external dependencies. Yeah, they are responsible for that. So I'm trying to reverse that normally. So first of all, I'm trying to find the mistake in my code. And how to do it? I basically run all the tests. So instead of 5 hours working, after 2 minutes, I had results that everything works on my side. I had mocks of responses of FPF, API, all the data was there. So right now, I'm sure my code works properly. So it took me like 10 minutes to realize that something has changed in the product side when I was redirecting my user. So the problem was not on my side, basically. And it took for me like 10 minutes or 20 minutes to find the problem and address the problem. And my work was done, basically. And next week, the product owner came in and he said one more time, "Yes, sorry, the code doesn't work." And I ran the test and I found another external dependency. So I spent like 40 minutes. But if I don't have these tests, I would spend like 5 hours debugging first day, 5 hours debugging next day. So it's altogether 10 hours. So basically for engineer, 5 hours working is like full day of work. So I would spend 2 days just to investigating something that was caused not by my code. But still, I was able to save this time using test-driven development. So how to be more efficient? And basically, the answer is think first about use cases. Think first about the business requirements. Because, yeah, I work with engineers, I am engineers. We just love to create new toys. We just like to do things that basically work. And wow, it is amazing. I use the new technology there. I use new design patterns. It is amazing. Yeah. But still, we are doing our work because we want to achieve some business goals, and this is the most important. And thinking about the use cases, thinking about writing proper tests for that, can help for us to improve delivery time. We can be more sure about the code that we are creating. So basically, test-driven development, and I like really talk about it because test-driven development is very simple. It's like write tests, then write the code that pass the tests, and then write tests and write the code, and this is the loop. Nothing more. But what is important here, we can change the tests in the future. We can change the code. It's something like when I create the payment module and I want to write first tests, it's not like I will connect that with the external API and I will demand all the information or do the processing. It's like, first of all, I just return the flag that, okay, this is true, it was paid, or this is false, it wasn't paid. Because then this abstraction and logic inside will be growing and I will just start improving my tests. But what is amazing here and what I really enjoy when working with my team is that our perception of problems and tasks will shift and will change. So we'll be more focused from the first minute on the good solution that can really fulfill all the requirements. Because from my experience leading teams, there are scenarios when people having this hardest part, the biggest challenges to the last moment. And like they are working on something 1 week, but the most crucial part, for example, for the business, they are waiting until the first day afternoon. So because they are working on the most pleasant, simple things, and then on the first day, it's like, you know what? I have 2 very, very difficult questions. And then they are starting, thinking about the problem that should occur basically on Monday. And working with test-driven development is something that enforce this thinking about the features first, because you already started testing that without writing the code or the other solution. Of course, it's not only about the coding. Okay. And let's wrap up a little bit these fundamental tenets of test-driven development. So, clear requirements and design. When I know that today I will be writing the tests first, then I will ask a lot of questions about definition of done, for the task that I want to make. And it really impacts the sprint plannings because the people, they ask a lot of questions. When they've been, Uncle Bob as well mentioned the process of creating software for Apollo. And it was like the engineers at the morning, they were writing the tests, and there was 1 day sprint basically, and the rest of the day they were just writing the code that can pass the tests. And I can see that sometimes when some people in my team are stuck with something or they don't understand fully the business requirements, I'm helping them to write the tests, for example. So we are sitting together for like 30 minutes, and even though sometimes they don't understand what the code should do, when you are finishing writing the tests, they can realize, aha, okay, I understand that now. So basically, I like to do that as pair programming to create the contract between the developer and the software. And Don Quixote is one of my favorite books, basically. And Hitchhiker's Guide to the Galaxy, the second one. So don't panic, yeah? And improve code quality and confidence. Confidence means we are not afraid touching the code. This is very important. We are not afraid touching the code. When we have everything covered, like the procedures, all the tests, we understand how it should work, what is expected behavior, then everything is automated, then we can do really fast, very good refactor of the code. So we can improve everything. And it's called red-green refactor. So it means that when we change something in the code and we have this red color, then we should reverse that to the green color by some changes, and that's basically it. And okay, so how to start basically with test-driven development? I really like the katas, so basically some challenges for the developers and write some basic tests, and that's all. Don't do it on the real job because you will waste a lot of time at the beginning. So, but I think 2 or 3 weeks, just like 30 minutes per day, and it will be enough.
All right. Any questions to Sebastian? All right. I guess it was all out there. There is one.
So one question I have is, do you really use the test for documentation? And the reason I ask that is whenever I come into a new code base that I'm not familiar with, I never use the test. I never look at the test to understand it. I never find that useful. I always personally find it much more useful to actually look at the code and read it rather than look at the test to understand what the code is doing. So like, I know that's not the main feature of TDD, but I've heard it and you mentioned it. So do you actually find yourself doing that when you come to a new code base? Do you look at the tests to understand what the code does?
Honestly, yeah, I didn't realize that, but yeah, I have the same experience. When I, see the new code base, then the tests everywhere, they are basically written in a different way. So yeah, but still, when I work on our project in the startup, so I work on the same code base for 1.5 years, and I will be working on that for next 5 years. Then for me, it helps a lot. Yeah. But still, when someone writes the test, I sometimes ask myself, okay, what it means basically. And for me, in new code base, always the best source of information were pull requests. So check the ticket, check what changed, because the big number of files that you just want to read and analyze can be overwhelmed.
Hi, do you have plans to support Gherkin syntax or BDD in general?
Yeah, I've been working with that in some projects, but sometimes the complexity costs too much time, basically. And you need to extend the language, extend the whole syntax for that. Yeah, it helps, but about the testing, I feel more, for me, it's more interesting how the AI browser agents will work in the future. Because one of the plans that I want to do is to use this AI browser agent to prepare the scripts, how he should test the application, and then he should log in, verify data sets, etc. So I think.
All right. Any other questions for Sebastian? Okay, one more.
Hello. I'm finding that when I'm looking at tests that are written for software, they're usually thinking in terms of isolating behavior to this application. How do you think about scenarios where we have many, many more inter-service dependencies, and so you might end up spending as much time building mocks as you are actually testing the software? How do you think about that in these more complex, big architectures we find ourselves in?
In most cases, testing is interfaces. So in that scenarios, I'm more focused on testing interface, and this interface should behave in the proper way, basically. So. Gotcha. For complexity.
So when you have many layers of applications that are now built on top of each other, and we're mostly thinking about, like to your point, like when you're looking at the software, you want to think about the outputs and whether those are the correct behaviors. How do you verify that the behaviors of many layers below you are not indeed the cause of some resultant behavior on the other end, basically?
That's a very good question, basically. And what is important here to mention that not all the code is good for testing, basically. So when you write code without tests, probably this code will be very hard to test. So this is the first approach. So when we write tests and the team knows that they will be forced to write tests, then we'll change the solutions, because it cannot be, like 100 services in one service without dependency injection, for example. Yeah. So.